Hey, hi everyone. Welcome to CodeTav Management. So today we will discuss about the JPA relationships and queries, the N+1 problem. Earlier video we have discussed about the one-to-one mapping related architecture and some internal topics. And if you will go to my the Spring Boot discussion playlist, then there you will able to see the one-to-one, one-to-many, many-to-one, those JPA relationships. The N1 plus problem also I have discussed earlier, but here in some other way I will try to discuss. Okay, so thing like if you are building an enterprise Spring Boot applications which will mapping a single table, that is easy. Okay, but what happens when you will build something like there a user has 50 orders or when 100 students enrolls 100 courses. So if you map these relationships incorrectly, then Hibernate will secretly fire hundreds of hidden database queries and crash your server. So today we are doing a massive deep dive into JPA relationship mappings. So we will cover the one to many to one, many to many. Okay. So then we will unlock the magic of Spring Data Derived Queries. What is the JPQL? Finally, we are going to tackle the most asked Java interview questions in the world of like the N+1 query problem and exactly how to fix it using join fetch. Okay. So that are our agenda. First of all, I will going to discuss about the relationship mappings. So first one is one to many unidirectional. So let's start with the most common relationship. That is the one many one to many. Like one user has many orders. So like if you just slap a one to many annotations on a list, Hibernate will panic. Why? Like it cannot store multiple order IDs in a single user row. So it creates a completely new third database table just to map them together. So in a real production system, we don't want that extra table. So we fix this by taking the control of the foreign key using the join column annotation. Okay. So here, if you will see, we have the entity of user. It has the long ID. Okay. Now we have the one-to-many and cascade type as all. So we forces the foreign key into the order table instead of a mapping table. So orphan removal also we have set as true. Okay. Now join column name user ID and private list of orders. Okay. So what we are doing here, we are forcing the foreign key into the order table itself. And instead of mapping table means we are not gonna create the extra third table. So here some important note, what is orphan removal? So here we have set the orphan removal as true. So if I remove an order from the list in Java, then Hibernate automatically executes a SQL delete statement, okay, to remove it from the database. So it is perfect for shopping cart items or user addresses. Suppose from the Zepto you are ordering some 10 items, then you wanna uh, delete one order, and instead of 10 items, you gonna order 9 items. Okay, so in the backend, that thing is happening is through the delete query. Okay, it deletes the row from the database. So it maintains referential integrity, right? Now we will tell about the many to one and many to many. So one to many is the unidirectional. So conceptually, many to one is also unidirectional. So it is actually the most common relationship in real applications. Like many orders belong to one users. So in this setup, only the child means the order holds the reference to the parent. And for many to many, what is happening? So things like student and courses, like because a student can have many courses and a course can have many students. So Hibernate must create a joint table like student course. Okay. So that joint table will will be generated, and you cannot avoid it here. So there, the join table required. But for one-to-many cases or the many-to-one cases, you can force the foreign key into some your another table. Okay, suppose where it is one-to-many, in that order table you can create instead of mapping the table. Okay. Now the next topic is like Spring Data JPA magic. Okay, with derived queries and pagination. Okay, so what is the derived queries? Now, like how do we query this data? Suppose we are gonna take to look on to the database, like or from the source of the data, like what is the data for that? So to handle this from our Java, we have some methodologies. So from them, the first one I am going to tell you about the derived queries. So this Spring Data JPA has a magical internal engine. So suppose like if you name your repository methods following specific rules, then Spring generates the SQL for you using a class. What is that class? That is the part tree. Okay, so that is basically a parser. So through that part tree, okay, uh, from that class, that all those things will be happen. So method must have start with find, read, get, count, exist or delete, followed by and the field names. So you can see here, like by public interface user repository, extending the JPA repository, and here we are going to do like find by name and phone. So internally, what it generates this query. It generates lake star from the users where name, what, and phone what. So that phone and name will be passed in these attributes. Okay. Now find by name in. So that means like select star from users where name in, and there it will be passed the list of string of names. Okay. So if you are returning thousands of rows, you will run out of memory. Okay. So you must use the pagination. So by passing a pageable object like page request of, you can see here, right? We have passed like page request of 0 to 20, like page 0 to 20 records per page. Okay. So you tell the database to only give you 20 records at a time. So the return page user object gives you the front-end friendly metadata, like total pages and total elements. Okay. So the page object contains useful metadata for front-end tables. Total pages is first, is last, and total elements. Okay. So in the service layer, you can use that pagination. So that is a very much important topic, like in Spring Data JP, like querying the through the derived queries and use the pagination. Now the next part is JPQL and modifying. So what is JPQL? JPQL is the Java Persistence Query Language. So derived queries are great, but for complex reports, you need the JPQL. So the golden rule of the JPQL is you write the queries against the Java entities and fields, not database tables and columns. So JPQL is also the database independent. If you will use the JPQL, then uh, it will you can use it for any database. Like suppose currently you are using some Oracle database. Okay. Next, you are going to use the MySQL. Okay. So those things actually, like the versions will not dependent on that. So it will be only dependent on the entities. It will do the queries according to Java entities and fields, not the Java database tables and columns. So Suppose you have written this query, like select u from user u, where u.email email. User find by email custom, param email, string email. Okay. So like if your query alters data, like update or delete, then JPA requires you to add two annotations, modifying and transactional. Otherwise, it will throw an exception. Okay. Now the N+1 problem, what is like that is the performance killer and what it is actually. So listen closely, very much, like because this is guaranteed to come up in your next interview, like it can come. What is the N+1 problem? So like imagine you fetch 10 users from the database and that is one query. But each user has a list of addresses loaded lazy. So when your code loops through those 10 users to get their addresses, then Hibernate fires a brand new query for each user. So one query to get the users and 10 queries to get the addresses. So total 11 queries, right? So if you fetch 10,000 users, then you just fire 10,001 queries, right? Your database would be dead. So what will be the fix? So solutions to N+1 is join fetch and batch size entity graph. These are the solutions. So what is join fetch? That is the best solution. So forces the Hibernate to execute a single inner join or left join and grab all the parent and child data at the same time. So in Java, we can use like query like select u from user u, join fetch u dot addresses. And then we are using this find all users with addresses. Right? So this forces the Hibernate to grab everything in a single massive SQL join. That will be beneficial for us. Next is batch size. So instead of fetching addresses one by one, Hibernate fetches them in chunks. Like batch size, if you set as 10, then it grabs the children in chunks of 10 and reducing the queries significantly. So if you have 10 users, it takes one query for users plus one batch query for addresses. So total two, one query for users and one query for addresses. Okay. Now next is entity graph. So entity graph is a declarative cleaner annotation based way to tell the Spring like which lazy fields to fetch eagerly just for one specific query. So a declarative way to tell Spring to temporarily treat a lazy field as a eager just for the specific method execution. So in Java, you can write in that entity graph attribute first addresses. You need the addresses find all. Now flash versus clear. So those are mainly for your memory management. So Flash actually synchronizes the internal persistent context, which is your level one cache, with the underlying database. So it pushes SQL statements but doesn't clear the cache. So it pushes the SQL statements but doesn't clear the caches. Okay. Next is clear. It completely purges the persistence context. So totally, it will be cleared. So any subsequent reads will hit the database again, and instead of returning cache memory, used heavily in batch processing to prevent memory leaks. Okay, so you can explain the flash versus clear during the memory management in your interview, right? So flash synchronizes the internal persistent context with underlying database. So it pushes the SQL statements but doesn't clear the cache. But clear completely purges the persistent context. So any subsequent reads, it will not hit the persistent context or your cache. It will directly search from the DB. Okay. So during batch processing, to prevent the memory leaks, it will be used. Now, some industry best practices what we follow. So uh, the main point is like Never return entity directly from the REST APIs, always map them to TTOs. Solve N+1 problem before production, so it is the one cause of slow Spring Boot applications. Next is prefer many to one over one to many. It is generally more performant and easier to manage the foreign. And interview gold is like derived queries are parsed dynamically by part 3. So JPQL works on the object model, not the relational model. The N+1 problem is caused by lazy loading, collections inside a loop, and the most efficient fix is utilizing a join fetch. So join fetch, batch size, and entity graph among them, join fetch is the more easy. Okay. So what is plus versus clear that I have described? How are direct queries parsed? That also you can answer like through the part 3 class. What is the best fix for N+1? I have explained you through the join fetch. You can that is the best approach. What does the orphan removal do? So it ensures the referential integrity by deleting child rows when removed from a parent collections. Okay. So if this masterclass helped you understand Hibernate relationships and performance, then hit the like button, subscribe to CodeTav Management, and I will see you in the next one. Okay. So that's all. Support me. Thank you, everyone. Bye.